Hello everybody, this is Ben with another Minecraft video. So, previously I made a 5 by 3 numerical display, which, while compact, was not very practical for your average survival world. So I wanted to show how to make a slightly larger 7-segment display. So, taking a look behind the scenes, we can see a memory cell that stores the information for the number. We can see inputs and outputs. Outputs that go to our screen, our display. Down here we have our carryover circuit, which whenever this hits 0, it will send a pulse over here. And then if we add a second one here, it will trigger that one. So we can carry over from 9 to 10, and then from 19 to 20, and so forth. Here we have a timer that just pulses to progress. You can put any signal here, and it will add one to the counter. We'll see that later. And down here we have a reset. We have a reset here. Which resets this back to, well, in this case it's at 2 because I was messing around with the timing. To make that go faster. But yeah, it resets it to 0. So there's a few designs I'm working on here. This one here is just your regular 2-digit display. You can see here how the output from this line goes up into the input for the next line here. And in this way you could daisy chain any number together. Over here I was working on a way to count items. This actually worked for a while and then stopped working. I didn't update snapshots or anything, it just ceased working. I don't quite understand why. The idea here is that I want this hopper to be depowered long enough for an item to slip through. Because what happens if you what happens is either this doesn't go on or this goes on and stays on. The snapshot's pretty buggy right now, so I'll wait until we get 1.5 before I really start tackling things like that. But I made a slower version that just uses one of these to count. But as you can see there, I put in, oops, I forgot to reset that. Let's reset this first and then try counting the number of diamonds we have there. So I do want to do something My original idea for building a display was to count the number of items I have in inventory. So I can track the number of diamonds I have or the number of emeralds or whatever using my automatic sorting system. I don't know if I'll actually do that because doing a display this size requires quite a lot of space. Is that not hooked up correctly? That's going in there. There we go. Nine, and there should be 10, and stop. Very good. So yeah, building a bunch of gigantic displays isn't really practical, so I'll have to figure out some other way of measuring the number of items I have in inventory, maybe. And also, there has to be an easy way of subtracting and adding, because, of course, if I take a stack of diamonds, then I'm going to have 64 less. So, I'll have to figure out some other way of doing it. But, I mean, if you only care about one thing, this display here will do it fine for you. You can count up to 999. You can count up to 999 items. So you can see here we have 64. So it successfully counted the number of items we got there. So I'm going to build this one here, probably over here, and we can see how it works. The heart of this system, and the thing you should build first, is the memory cell. This is simply a piston ribbon. That consists of 8 columns, 7 deep. Now, these 10 columns relate to the 10 numbers, 0 through 9. And these 7 rows represent the 7 segments. This way you can store all 70 bits of information that goes into this display in a fairly compact form. I guess you could make this smaller by splitting this up in half and putting a 3 wide ribbon behind a 4 wide ribbon and wiring it up, but that's kind of complicated for a tutorial. So I'm going to start building it over here. So I have a line of pistons all ready to go here to start with. I like building these off the ground, and you probably also want to build them kind of far back from the display just so that you have room to put your redstone. Because it can get kind of claustrophobic here at the beginning, and having enough room is kind of important. So I'm going to start with 7 pistons on the bottom facing upwards. Now your piston ribbon is going to start here. You can go up 3. Now Now, next you want to do your, let's go with the right here. Next you're going to put repeaters going out. Now these are your outputs, and actually you can replace every other repeater with a line of redstone. 2, 3, 4, 5, 6, 7, 8. Did I miscount? 8. Oops, I did. This is supposed to be 7. Why not 8? Okay, that looks better. These are going to be your outputs. On the other side, you're going to put 2. You want to put levers and then repeaters. You can also just do one lever and a line of redstone, but levers are cheaper than redstone. Okay, and then on top of this, we're going to put these pistons facing this way. So the easiest way to do that is just now we're using non-sticky pistons for this because we don't want to pull back the blocks. We want to just push them. Okay, then we're just going to put a line of wool on top here. Now we're going to do a kind of U shape, as seen over there. Then we're going to put pistons going facing down. Like so. And we're just going to redstone this whole thing up. Now we want to put a 1 tick repeater here because we want to delay this one by 1 tick. That way they don't try to push into each other, which will cause it not to do anything. Let's put in some more ribbon here. We'll put 2 here because we don't want anything in front here or in front down there. And we're going to go down 3 here. And then finally we can go over 2 here. So it's going to look like something like this. Now we just need to put in our last pistons, which are going to go right here. These are kind of tricky to put in. I'm actually going to just remove these to do this fast. Come on. Very good. Okay, So we got that done. Now we just need to put a blocks over it. And then redstone that up as well. So this is the start of our design. Now we just have to connect it together, which I'll do in a sec. Okay, let's wire this all up together. So we want to do a diagonal level here. Want to put a 1-tick repeater here. And we want to put, we're going back here. Right, I forgot about that. You need to use a, I don't know why I got rid of my redstone there. You have to use a torch there because otherwise it does that. Okay, so, do that do? That push these up. Yeah, one of the issues with this memory cell is that if it messes up, it will break something. Unfortunately, normally you can put either furnaces, obsidian, or any other immovable object somewhere in here, but in this case you can't. Well, I guess you can put them here and back here and here. Okay, I lied. But you can't put them up here. So, of course, actually you could make these furnaces. And then they wouldn't be pushed anymore. That too? Yeah. Never mind. I forgot we could put redstone on immovable objects. But I'm going to replace that with wool just to keep the looks. But yeah, never mind. And I put that in the wrong place anyways, because these pistons aren't in danger of being pushed this way anyways. Okay, anyways. So this is all hooked up. So what's going to happen is power's going to go through here. It's going to trigger these pistons here and these pistons here at the same time. That's going to move this over and this over. Then 1 tick later, the power is going to come to here and come down here, which is going to move it up and down. In order for this to work, we need a 1 tick pulse to go through here. So we're going to replace our non-sticky piston with a sticky piston, or drop it on the ground, either way, like so. And we're going to create a monostable circuit, which is just a fancy way of saying a 1 tick long pulse maker thingy. So we're going to put a sticky piston with a block and some redstone. And when we power this line, it will cause this block to be powered, which will cause this piston to extend, which will cut off power. So this will be powered, the power will be cut off, and that turns out to be just 1 tick long. So I would test it, but we screwed up here, so I'm going to quickly fix this, and we can test it out. Is that the way to do it, or is it the other way around? the other way around. So this one should be. And this one should be. There we go. Okay, let's test it out. Nothing broke. Very good. So you can put a timer on this. Fairly easy timer to make is just 3x3. You want a torch. You want 3 redstone. A repeater. Set to how long you want your delay. That causes a nice firing. Okay, so now you have your memory cell. You have your outputs. Now you want to build your display. I'm going to be building this out of quartz because I build everything out of quartz these days. You want to go at a fair bit so that you have enough room to work. And you're going to start your display here. I like to line it up with the center of my display with the center of the memory cell. So I'm sure you've seen 7-segment displays on your alarm clock or your microwave. They're pretty straightforward. One thing I don't like about them in Minecraft is that you have these corners that you really can't do anything with. So I'm not going to fill in the middle just to kind of help illustrate everything. How we're going to power these is like so. I want access to be below. So if you put in a redstone signal like that, it will light up. And actually, I'm going to use different color wools for each of the inputs. Just to make it easier to follow. And black. We'll go with black down here. Okay. So now we just need to hook up these 7 to these 7. And then all we have to do, then after that, we have to add glass blocks to these displays. And then finally, we probably want to add the carryover mechanism. So we'll start with wiring up the display. Wiring these up is pretty straightforward. You just need to make sure you don't cross the streams, if you will. Otherwise, it's pretty straightforward. I like to alternate, so this one's going to go up, and this one here is going to go down. You don't need to. You can do whatever pattern you want. So I want this one here to be the purple, so we'll go up. Is that gonna work? Maybe, maybe not. Let's see. And that will also have to be a repeater so it doesn't power it. And then we should be good to go here. Alternating it has the advantage of not having two next to each other, both try to go the same direction, which minimizes the amount of I need black. The amount of headaches you have in trying to wire these. Or see issues like that, so you know, each person's is going to be slightly different with different requirements. But I'm going to finish wiring these and then I'm going to get back to you. So, see you then. As you can see, it's a simple wire job here. I use color wool to help me distinguish where each line is going. Now that we have this wired up so that every output lights up a separate segment, we can now change up the blocks here to make some of them glass so that we can control which ones are on and off. So I'm going to jump over to Excel and explain a little bit more about that. I made this Excel sheet to help me determine what has to be on and off for each number. Up here you can see that. So for example, for the number 0, every segment has to be on except for segment number 4, which has to be off. Likewise, for the number 1, most of them have to be off except for number 3 and 6, segment 3 and 6. In this way, it's easy to determine what has to be on and off. Next, we have to convert this into a linear order of air blocks and solid blocks for our piston ribbon. So this is the order that this is written in, 1 to 7. Below it, I put in the order that my blocks or my outputs are actually outputting. So, for example, the piston or the block on the far left of my memory cell corresponds to the fifth segment here. The one next to that, the second. The one next to that, the 7th. The one in the middle goes to my 4th, 1, 6, and 3. Finally, I took this order and reordered these that way so that I can have my outputs as I'm going to put them into the actual system. So for instance, for the number 0, I need to have 3 blocks. One, I'm using air, but this is actually going to be glass. And 3 more solid blocks. For the number 1, I need 5 glass blocks and 2 regular blocks at the end here, and so forth down the line. 8 is easy, just 7 solid blocks. So I'm going to take this and go to my world, and I like to do these in order from 0 to 9, so I'll start with 0. In this case, I'm going to go down to this line, start knocking out blocks. So in this case, the 4th block is going to be a glass block, and the rest of them are going to be solid blocks, and that's going to give us 0. I'm going to take a button here, to advance it 1 space, so I get a clean grouping, and this is going to become 1. Now 1, if you remember, was 5 glass blocks. Get you, yep. And 2 regular blocks at the end. So that's good. And I'm going to keep doing that until I finally reach the 9th one. So I'll do that off camera and then get back to you. And there we go. 9. So now these are all set. We can take a look. Excellent. And you can actually speed these up quite a bit. So. In fact, you can actually do it a little bit faster than that. Because this works at a 1 tick pulse. So you can get it quite fast. Okay. So the next thing we want to do is detect when this hits 0. And when that does, we want to send out a pulse to the next one in line to carry over. Now, we can do that in a couple of ways. We can... The easiest is simply to work with this center one. So in this design, the 4th segment is in the center here. It's this light blue wool. So I just grabbed the signal off of that and brought it down to the ground here. At the bottom you want some way to filter out the flashing that happens. So as the pistons move the blocks around for a brief second, there's no block in between these two as they're being moved by the piston, so the signal will be cut off. That will cause this torch here to flash normally. Let's just get rid of that. So, you can see there that flash. We don't want that. So you can add 2 repeaters, one at 1 tick, one at 2 ticks. That goes to this torch, and that will filter out that will basically keep the flickering from happening. So now we want to convert this signal into a one tick pulse. So we can do that by using a sticky piston and just a regular block, and then a repeater after it. When this is powered, it powers this block and the piston underneath it. The piston extends, cutting off the power, which results in a one-tick pulse. This is also a compact rising edge detector, which will only trigger when a line is powered. So we want that to run to a block with a torch on it, and then we want to do 2 redstone, and then 2 repeaters, and then 2 more repeaters. This is a clock. How this works is that when this torch is turned off, these 2 repeaters will turn off, which will unlock these. Then we're going to have a redstone signal in one of these, and basically these will be turned off for long enough for that signal to move to the next one. So we'll cycle through. That 2 ticks. Sometimes if you do a 1 tick delay, the torch won't go off. There we go. So now this signal will go back and forth, and we have to make sure that we have lined this up correctly to correspond to the right number. So you're at 6, 7, it should turn off. 8, 9, and 10, it should turn back on. Excellent. So then we can use another sticky piston here to create another rising edge detector that will then go off and be connected to the next display in line. Now, how you want to connect this is you want this redstone line to ladder up here and connect here. Whenever you put any input in here, it will cycle this one for you. That's also how you can get inputs to begin with, like this clock is doing the same thing here, putting in there. Now there's a second design you can do to create a trigger if you don't want to use the sticky piston with the block on top. This also works pretty well. It's not as compact, but it works the same way. It is a 3-tick repeater going to a block with a piece of redstone on it, then another block next to it with a torch that has a line of redstone going into it like that, then a torch on the other side. And this is a rising edge detector, so it only triggers when this line gets powered. And it creates a 1-tick pulse. So you can use this design instead of the sticky piston design in your build. The last thing we want to do is add a reset button to this clock, to this numeric counter. So we can reset this to 0 whenever we need to. The basic idea is we'll have this clock and we'll have this 0 detector. So we'll just run this clock until the 0 detector triggers and tells us to turn it off. Now the cool thing about this clock is you can turn it off with a redstone signal anywhere here, or by powering this block. Now I kind of built this whole thing a little bit too far out, so normally I would just do a torch tower under here, but that's not going to work, so let's just build our thing over here. So first we're going to want 2 blocks. This is a basic design of a flip-flop. When you put, so you have 2 inputs, 2 blocks. When you put power into one, it flips over to the other one and stays that way. So you can So what this will do is you can press the reset button any number of times. After the first time, it won't do anything. So we're going to hook the reset button to one of these. When it triggers, it will trigger the clock to start. Then we'll attach the zero detector to this block, which will turn it off. And that's how we'll reset the clock. So let's do that. Put the reset button here. I want a repeater here somewhere. Okay, so that will trigger this. When it triggers, it will cause this to be powered. So we want this to turn the clock on, so we have to invert this signal. Okay. So now what's going to happen is when this is off, this is going to power this clock, turning it off. So we'll be able to remove this lever in a second. Now we also want the 0 signal to come in here and turn this off. So if it's at 0, it won't be, it will turn off, so it will stay there. I'm going to use one of these falling edge detectors again, because I want to, this stays powered from 0 to 7. So if I hit the reset button and it's at 3, and this is powered, this flip-flop will shut itself off automatically, so it's not going to work. Okay. Let's test this out. I want to set this to 2 ticks there. 9 and 10. Oop. That'll do it. Sorry, it has to be over here to this one. Try that again. So we're going to go over here. We're at 7, 8, 9, and then 10. We should be shut off. Now there is some latency in this system, so if your clock is running too fast, sometimes it'll overshoot its intended target. Yeah, see, that went up to 2 because it was just too fast. So that's one drawback. So if you're going to reset your clock off or your display often, you probably want to come up with a faster method of shutting it off. Now for multi-segment displays, resetting is slightly more challenging because you want to avoid cascades. For instance, if you have these 3 displays and you set them all to reset automatically, and this one was at 9 and this one was at 3, then the 9 one would finish first, going to 0. Then this one, which was set to 3, would finish later, but because of the mechanism, it would carry over the 1, and this would have a 1 instead of 0. You could disable carryover while clocks are resetting, which would be faster but more complicated because you'd have to determine when all of them are done resetting, or at least all the ones downstream are done resetting. Or, sorry, upstream are resetting, which seems like a hassle. Instead, I prefer simply linking one reset cascade to the next. So when this is a slightly different setup than the one over there. So here is my it uses a torch tower going in there. So here's my input to shut the reset off, which then also powers this line of redstone over here, which carries over here, which starts this cascade or this reset here. When that's done, it then causes this reset, and you can carry that on forever. So this is slightly slower because each number is reset individually in order instead of all at once. But it's much more reliable and easier than trying to figure out how to reset them all at the same time without getting carryover. Those are the basics you need to build a clock or a display in Minecraft. But that's certainly not the end of it. There's a lot more stuff you can add. You can make clocks that go backwards and forwards. You can display characters other than numbers, letters, or symbols. You can make them faster. You can do addition and subtraction with calculators. The possibilities are endless. But I hope this little tutorial has given you the basics you need to understand to kind of go out there and start experimenting on your own. So I hope you enjoyed, and I'll see you next time. Goodbye.